Welcome to Hall 6, everybody. This talk is with Damjan. He's a CTO of Posedio. He's a resident of Vienna, and he did a very, very brave thing. When I did my research on him, he actually went for 2 years to Tyrol, coming from Vienna, which, as many people might know, is a brave thing to do, since Tyroleans have kind of a prejudice on people from Vienna. But I'm sure he did great. He's a very, very seasoned tech enthusiast. He's a systems architect. I was told he's very, very much into technical books, but only hardcover ones, the printed ones, not this ebook crap. Please give me a hand. He's one of the greatest guys we can have here in Austria, at the Cloud Native Days Austria. What is a platform? Please enlighten us.
Thank you, thank you. So, thanks everyone. Let's see if we can get the slides up. Otherwise, you'll just have to listen to me talk without slides. Presentation is on, but let's restart it. So, slideshow. Start. Oh, seems nice, except now you see the full thing. There we go. Nice. So hi everyone and welcome to today's talk. Today I will try to kind of talk about what is a platform and try to get you on the journey of finding that answer together. This is what I look like when I try to talk about what is a platform. So a platform means many things to many people, and usually it's very difficult to explain or to agree on a single kind of definition of what it is and what it should do. And yeah, I mean, I say I look like this, but I can actually back it up. So this was the first draft of my talk, what I wanted to achieve, what I wanted to talk about. Sketched it out, tried to get all of the kind of aspects, different aspects of it together. And hopefully by the end of the talk, we can kind of agree on the basics of what a platform is, or at least what you can do to kind of build a platform and to make use of it in your organization. But and of course, hopefully the slides following will be less chaotic than this one. But first, let's start with an introduction. So hi, my name is Damjan. As already mentioned, I'm a tech enthusiast interested in Kubernetes, interested in all things cloud native, interested in platform engineering, and I've kind of worked on platform engineering and platforms in general from many aspects. So I've tried to kind of look at, or I will try to look at these things today and give you a sort of common definition of what a platform is. Why do I want to define a platform? Well, I've started my career as a software developer. Then I worked as a DevOps engineer on a large transaction processing system where we wanted to iterate very quickly and deliver very quickly. So it was important that the team was able to do more or less everything. So kind of the team was the platform. Then I worked as a platform engineer on a large developer platform. I am currently supporting a data platform, and I have also helped establish SRE practices in a team. So kind of done a lot of things. But this is not the point that I want to get across today. So the thing is, I still struggle with convincing or getting management, developers, and platform engineers to agree on a single definition of a platform. So we all kind of intuitively know what a platform is, but when we talk to each other, it's very difficult to say, okay, this is a platform and this is what it should look like. So how many of you here are platform engineers? Maybe show of hands. Nice. And how many are using platforms as developers? Nice. So the usual problem that I have is, like, whenever I talk to one of these groups, they can, or two of these groups, they can always agree on who the third group is, but when you try to get all of them together, it's never the same group. So it's a bit difficult to explain or to agree on what a platform should be. And this I don't have in the slides, but I thought of it today, like a perfect metaphor for this attempting to get everyone to agree on a definition is this story of the blindfolded man with the elephant. So the story goes like, if you blindfold 3 people and tell them to feel out an elephant and tell you what an elephant is, essentially you will end up with someone touching the tail, and they'll be like, yeah, it's like a snake and has this fluffy end at the bit, and someone will touch the trunk, and they'll say, well, it's a bit thicker and it can move around, and someone will touch the leg, and they'll be like, yeah, it's a big thing, and then the thing is, none of them are wrong, because they all saw it and felt it, but also none of them are right, because none of them sees the whole picture. And this is what I hope to contribute today, to give you kind of the view of the different roles that I've had throughout my career, and to try to get like a bigger picture of a platform. And I will point out through the talk like what I believe a platform is and why, or which aspects or which different roles have given me a different insight into what a platform can be. So the first thing is, in my experience, you usually don't start with the definition of a platform. You start more of like with an idea of a platform, and you don't know what it is until you've built it. And then once you've built it, you're kind of, well, we've built it, so now that we have it, this is what it is. And it's a kind of interesting approach to life, I would say, but it's also this like Schrödinger's cat or Schrödinger's plate, because no cats were harmed in the preparation of these slides. But essentially what it means is like you don't really know what a platform is until you get there, and then you have it, and then there it is. And this kind of has a secondary implication, which is you define a platform by what it does. So you say a platform is what a platform does, and then if you dig a bit deeper, what this means or what this implies is that a platform is essentially defined by its goals. So you build it to do something, and then you look at what it does, you see if it achieved its goals, and you say, well, this is what the platform is. And this is where I will take my talk. So I will go through sort of 4 goals that I believe are kind of similar for all aspects of platform engineering and platform work. And I will try to point out why these goals, I believe, are useful for platforms and how they contribute to the definition of the platform towards the end. So I'm glad that my talk is just after the keynote where we talked about developer experience. So I won't be as eloquent when I describe it, but essentially what usually businesses want is more features, less outages. So you go to your management, you say, what should we do? And they tell you, give me more, but also make it faster, but also make it more resilient, make it better. And the problem is usually failures in systems are introduced by changes. So this is how it works. If you change things, it's more likely to break. But if you don't change things, then you don't deliver new features, so it's more likely to not be useful, or at least not be able to hold up to the competition. And essentially, this is the main problem that platforms try to solve. So this problem boils down to increasing productivity, right? You want to achieve more, you want to achieve faster with a platform than you can with just your company or your team size without a platform. The problem with this is that it works, but also it doesn't work. So essentially, the rule of you must be this tall to ride applies. So if your company is small enough, then usually it will suffer a productivity loss when it comes to building and using platforms. And this is because, in general, platforms add complexity. And the math is a bit weird. I'll come to that towards the end. But by adding complexity, obviously, you need to kind of have a sufficient size to be able to overcome this added complexity and to be able to break even or to make use of this added productivity that the platform brings. And you don't have to trust me about it. I brought a graph with me. So essentially, the point I'm trying to make is that as you are a smaller team, usually you have your workflow and you're relatively productive. And then as you grow, when you introduce a platform, essentially, when you're small enough, your productivity would drop because you add complexity, you change things, you make things less flexible, and therefore, by definition, productivity drops. What we are interested in is this break-even point, so kind of this point here where we say, okay, at a certain size, the productivity gains of a platform justify the added complexity, justify the work that goes into developing and maintaining a platform. So to reach this goal of increased productivity, essentially we need to ask ourselves, what can we do to this graph to make it to make the math work out. And Kubernetes is one of these tools which kind of surprisingly helps a lot. So initially it was designed and developed as an orchestration and container scheduling tool, but it has grown into this kind of platform of platform concept. So Kubernetes operators give you this ability to essentially define resources even outside of your cluster and allow a system that is built and maintained by others, designed by others, allow this system to essentially take care of ensuring that the platform components are running. So you can offload a lot of the things like authentication, like health checks. You can offload things like API calls, validation on your API endpoints, even to a certain level describing the resources. So all of this you can offload to a tool that is specifically built to help platform engineering. And this platform of platforms is actually a good pattern, even when it comes to things you develop in-house. It doesn't have to be like open source or external tooling like Flink or whatever databases or whatever you would like to have. You can use this for your own resources. So you can say, instead of having developers essentially learn Kubernetes and then use deployments and then deploy their applications, you could provide an abstraction layer and say, I have this custom resource called my application. The developers don't need to learn how deployments work, how Kubernetes works. They just need to learn my custom resource. They will deploy it. I will take care that policies are followed. I'll take care that it's scaled properly. So essentially, you limit the amount of knowledge a developer needs, but you also limit the complexity and therefore the flexibility of your deployments, and you try to make it easier to get to this deployment as soon as possible. This has, I believe, 3 implications. So one is, what we can do is we can move this curve to the left. So we are not essentially, or we're not effectively changing the productivity gain that we get, but we can get to this break-even point sooner. The implication here is, of course, that we also get to this loss of productivity sooner. And this, of course, makes sense, since if we are introducing Kubernetes as a separate tool, we add complexity. Somebody needs to take care of Kubernetes, somebody needs to maintain it, somebody needs to make sure that these resources, custom resources exist, they're well-defined, and so on. The second problem is obviously that when we introduce these custom resources, we limit the flexibility. So we tell developers, you don't have to learn how Kubernetes works, but you do need to learn how our custom resources work. And you cannot use essentially stuff that is not defined or not provided by us. And this can be problematic, especially in this early stage here, because also when you think of hiring and onboarding, essentially what you're saying is this industry standard that everyone knows, Kubernetes deployments, I will replace with my custom standard. And anyone that joins the company, you cannot rely on previous knowledge and experience. You need to teach them this custom standard. But then, of course, the productivity gain comes sooner, because then you take away all of the platform work that developers or platform engineers would normally have to do, and you rely on the mechanisms of Kubernetes to actually be able to deliver faster. So deliver faster means moving this curve to the left and getting to this break-even point sooner. But one thing that I mentioned here that I have kind of experienced in the projects is this trade-off between DevOps and platform engineering. So when you come from the development perspective, you want to be able to kind of have this freedom and use the resources that you want to use. So use deployments or use the things you know essentially to do the job. This DevOps approach tries to kind of combine this with the responsibility for running things. So they tell you, you still have the responsibility, you can still decide within your team what you want to use, but you're also responsible for running it. The platform engineering approach takes a bit of a different route. So they say, well, there is now a central platform team whose job it is to kind of move this curve to the left to get to this break-even point sooner, but therefore development and DevOps teams might need to give up a bit of freedom in order to be able to get to this. The next thing that a platform promises is stability. And Here, SRE is kind of my insight into this world, or my experience. And I would say it's not a coincidence that both SRE and Kubernetes as concepts track their roots in the same company. So Google is the kind of mothership for both SRE and Kubernetes, and they have kind of developed this way of running and stabilizing software. So essentially, when business says, I want stability, what they mean is, well, we want to standardize, because standardization usually means stability, because you standardize on tech stack, meaning you have less kind of esoteric, exotic things out there that you need to take care of. You standardize on a way of doing things. You have this golden path where you can say, this is how we deploy things throughout the company, and you can switch from project through project, and you always know how to deploy things. But you also importantly standardize on the rules of the game. So what this means is you, as a company or as a person in the company, know what the developer is allowed to do, what the developer is supposed to do, what an SRE team member is supposed to do or allowed to do, even what a manager is supposed to or allowed to do. So essentially, by stabilizing or standardizing the rules of the game, you take a lot of this ambiguity away, and you can focus on stabilizing the software. Like one famous example of SRE is the error budget and the deployment freeze. So if you agree on the rules that if you run out of error budget, meaning you have too many errors in a certain period of time, then you don't work on feature development, you work on stabilizing the code. Then it's clear to developers, it's clear to SRE, but it's also clear to business or to management that this is the invest that you need to take. In order for this to work, though, it's very important that the people that run the software also understand the software, and therefore it makes sense to both embed SRE team members into software development teams so that they have a feeling of what the software does and is supposed to do. But it's also important that SRE teams can kind of contribute to the platform itself. And one of the classical examples, and we hear today a lot about observability and OpenTelemetry and so on, metrics or observability can be a core feature of a platform, and SRE teams can make sure that you have these metrics out of the box for anything that runs on the platform. And this is a huge gain in terms of productivity, or in terms of productivity for the SRE team, which then equals stability for your applications, because the developers no longer need to worry about what kind of metrics they expose. The SRE doesn't need to worry about, do the metrics for different applications mean the same thing, or are they somehow special and different? Essentially, you agree on one rule, it comes out of the box, and you're able to, at 2 a.m. when the pager rings, when you're on call, you're able to say what is going on because you understand the metrics. The third goal that kind of businesses impose on the platform, and this is kind of sneaked into it from the side, so they talk about productivity, they talk about stability, but essentially what they also want and will come up with is almost always compliance. So the topic is always, we want to stop people from doing the wrong thing. In reality, the best you can hope to achieve is that you make the wrong thing so difficult that people don't do it by accident. So there will be always people who want to do, I shouldn't say the wrong thing, because in their context, it's potentially the right thing. So there are times when what you would normally stop in a platform, you would like to allow for specific use cases, but you want to make sure that it doesn't happen by accident. You want to make sure that this is always done because somebody needs it and because somebody wants to have it. So this is kind of my learning from working on data platforms, and anyone who has worked with data, immediately you recognize this. So essentially, GDPR is always a topic that comes up, and it's a perfect example of ensuring compliance within a platform. So what you would like to do is make it as easy as possible for people to exchange data, to use data, but as soon as some data is marked or recognized as GDPR relevant, you would like to stop people from doing anything with it unless there is a legitimate use case. And this kind of brings me back to what I said. You want to make it difficult but not impossible, because there are legitimate use cases for processing GDPR data. And so the goal of the platform, or what you could do with a platform, especially a data platform, is you could run data profiling or data scanning as a service of the platform, which kind of runs in the background independent of the work that the data engineers are doing. And as soon as you recognize something that might look like GDPR relevant data but is not properly marked or used, you just flag it and then you stop people from processing it further. The third goal today is, that I'll talk about today is transparency. So transparency in this case, I don't mean like transparency from a technical perspective, but more transparency for the business into what's going on. So startups usually have this chaos mode where you want to fail fast and fail often, and you want to experiment, what they call like making these small bets, so every engineer can have their pet project, try something out, different tech stack, different setup, whatever. And as soon as you see that something works, as soon as you feel that this is the best fit for the company, then you double down on it and you shut down the rest of the stuff. But enterprises don't work that way. Enterprises work with budget cycles. They work with planning committees. They have their annual roadmaps. They have their commitments to their customers, which in turn are also enterprises, which have commitments and so on. So for an enterprise, which is where this platform thing can be justified, a big part or a big aspect of what they want to achieve is this plannable work. So they want to know what can we deliver, when can we deliver it, but also they want to know what did we deliver. So what was done, what is running, what do we have, what is our portfolio essentially. And again, it's a bit of a trade-off. So usually when you recognize that this is a goal for the company, you try to sell the platform as in, yeah, this will be the tech stack. It's the only tech stack. Everyone will use it. We will know exactly what runs there. Again, this is usually not the case. So best case scenario, you can say not what you want to run there. So not this is the single thing that will run, but rather you can say what is actually running. So usually there will be some divergence again. So instead of this organized thing, you'll end up with kind of the mess, but at least you can say what is there. And this in itself brings a lot of value. So to recap, I talked about like increasing abstraction levels, which kind of means reducing flexibility, stabilizing the system, which means potentially slowing down changes. I talked about GDPR or compliance. I talked a lot about standardization, and this seems like a platform offers standardization at the cost of flexibility. And this is true, and it's same as all other software. It's true because simply as a platform engineer, you cannot anticipate all of the use cases. So essentially, you're building for, or you're optimizing for certain use cases at the expenses of others. And this is a bit of a problem because if I ask any of you today, would you be more productive if you can do what you want, or would you be more productive if someone kind of puts a limit on what you can do? Every developer will tell you less flexibility equals less productivity. So how does the math work out? So here I have LLMs, not LLMs, but I only use this as a metaphor. I'm not a statistics guy, so don't take my word for it. But essentially, my argument is whatever makes a developer as a single person less productive actually makes the company more productive. And it makes the company more productive because you look at kind of the law, similar to the law of large numbers. You look at like one developer always has a clear goal. They're motivated, they want to achieve something, and they want or know how to find the best way of doing things. The problem is when you add more developers, you get a lot of complexity. You get this kind of interactions between, you have unclear requirements, you have misunderstandings of requirements, you have a lot of meetings, and all of these things cost time. So where does the productivity gain come from if the thing loses on flexibility? Well, it comes through faster onboarding, it comes through less boilerplate, it comes through standardized solutions that you can just template and reuse. It comes very importantly from pre-approved processes, so you don't have to go through 3 steering committee meetings to get an approval to process some data or to use some feature. So if it's part of the golden path, then it's pre-approved and you can easily start using it and do it. It comes from easy or making easier lateral movements from project to project so that you can staff more important projects quickly by standardizing the tech stack and having people be able to work on different projects within the company. But also Lindy's law is an interesting example. So essentially, what it says is the longer something exists, the more likely it is to keep existing. And this makes sense in terms of software and platform, because if you think about it, the longer something has been used and the more often it's been used, the more likely it is that people already found the bugs. And if the bugs are more or less found or less common, then of course the thing is less buggy, the more likely it is that people use it. New software normally has more bugs because it has less users, less people have tried it. And finally, a lot of productivity comes from using, or in some companies' cases, abusing open source software, people that don't contribute back. But essentially, it kind of harnesses the community to be able to deliver things quicker and faster. And in short, this means productivity comes from improving or reducing the interaction between people, which of course with itself brings in the implication that this only works if you have a lot of people to improve the interaction between. So the bad news is that I can only tell you about the doors that I have opened, the plates that I have broken or not. And for me, a platform is essentially a tool that increases team productivity, increases standardization, increases compliance and stability, but at the expense of flexibility. And this is an important point. So two things here I want to point out, a tool and at the expense. A tool means that you can use it and you can also not use it. If you force an entire company to always go and use the platform, then you will end up with misfitting parts that you're trying to squash into the platform and it won't work properly. So you always need to remember this 80-20 rule. This is what makes or breaks a platform. You want to optimize the platform for the 80% of the use cases that you have that you can achieve with 20% of the effort. And for the 20% of the difficult custom use cases, you want to let people do what they think is best. The good news is that you get to decide what a platform is. So everything I've said so far is kind of my experience, but at the end of the day, a platform is what you say it is. You need to determine what it should be for your business, what's important for you. You can prioritize, you can set your goals, you can build the platform, and then comes a very important and often kind of skipped step. You need to ask for feedback from your users. You need to see, is this platform the right thing for us? Is this platform useful? Do we get benefits out of it? And of course, then you need to improve. Like any other software, a platform lives and dies by feedbacks from its users and by improvements, constant improvements. So thank you very much.
Since we're very good on time, I think we have lots of time for questions. I already see some hands. Yeah, let's start over there. I think that's the closest.
Thanks. What stood out to me is that you recommend embedding site reliable engineers, so people who have knowledge of how the platform works, directly with development teams. Because what I perceive working as for a very large company is an issue of silos. Just, having people talk, how to organize teams. Could you speak to that a little?
Yes. So there's two aspects that I had on the slides in terms of SRE, what I believe is very important. One is that the SRE need to be involved in the development of the platform itself. And the second is that it should be involved in the software development teams. And this is not always easy to do, especially in large enterprises, because the problem that you face is that you have a very small or limited set of SRE resources, but a lot of teams that potentially need support. And the second thing is, like you said, you have these silos where people have their kind of little kingdoms and everything is split up. And you need to be careful about what you can do politically as well. I believe that to get the most out of SRE, SRE people need to know what the software can do or what it should do. And it means embedding on a rotation basis SREs into the team where they maybe don't necessarily code, but at least can be involved in the process, can be involved in the work assignment, in the code reviews, and maybe even some pair programming with developers. And what we did when we started the SRE team in also large enterprise, essentially the first thing we did was, so there was an initial mistake that the SRE team was not involved in the platform engineering. The good thing is that some of the team members in the SRE team had previously been the platform engineers that worked on the platform, so at least we carried over some of the knowledge of how things work. The first thing we did is look for friendly customers, so friendly teams that are willing to try this out with us. And then we went on a kind of critical user journey discovery. So we said, okay, let's forget about most of the code base. Let's forget about what the application does with every edge case. Let's focus on the critical user journey. What can we achieve kind of end to end in terms of what must work for, I don't know, the customer to consider the interaction with our business successful. And we were able to even challenge the development team in a lot of topics where they believed that that it's important to have, for example, I don't know, cookie banners on the web page. And then we said, well, sure, cookie banners are legally important, but at the same time, when we talk about degradation of service, what we want to do is keep trying to offer a service even if the external party that serves these cookie banners doesn't work. So we said, can't we just say, as a fallback, we remove cookies if we cannot reach the external service, and then still go through the critical user journey? And this back and forth with the team, where we try to outline what for us is important in terms of criticality and what is important for them, led them to kind of trust us a bit more and led them to pull us into their development process and even start asking for advice and ask like, oh, we're trying to do this, does it make sense, can we? And it was a collaboration, but as all collaborations in the beginning, it's based on like people working together, so it cannot be mandated from the organization. This is why the best thing you can do is find a friendly team where you already have a connection or an understanding and try to pull them in and show them the process, and then hopefully word spreads a bit. And the next thing, of course, was focus on the most critical services in the company, so stuff without which the business really loses potentially millions of euros. And then you go to them, and they're anyway, I wouldn't say scared, I mean, they've been doing that for a while, but they also understand the implication of outages in terms of monetary value. So even if in the beginning they see it as a way of sharing responsibility, shouldn't say blame, at some point this collaboration picks up and it becomes kind of a two-way street where they understand the value that an SRE team can bring, and they're willing to accept this.
We had other questions somewhere over there. Yes.
One question from my side. What do you suggest in terms of process to improve and develop a platform further?
So the first thing that is critical to any improvement is feedback from actual users. I can give you an example. So when I started working on the developer platform also for a large enterprise in Austria, initially we had the idea that we start small. It was not meant to be a developer platform for the whole organization. It was meant as a platform for 3 teams that were working on one use case or one project. And then the thing grew, and then through some management decisions, it became the platform for the organization. And we added a lot of features that we believed were critical and useful. So we added features like secrets management, image signing. We added image registries, scanning for images. We added a lot of things which, if you read the blog posts or if you read the books, this is the way to go. This is how it should be done. And then I switched over from this developer platform to the data platform. And after like 6 months or so, I had to pull an image from the registry. And I realized that I cannot do it because I don't have my admin credentials anymore. And the description of how to pull an image without actually running it in the cluster, just pulling it locally, was just not good. And I had written it, so I can say it out loud, but it was just not good. And it took me, I don't know, maybe half an hour to figure out what I need to do with normal developer credentials. And then I realized, well, this is what our developers have to go through every day. So the thing that we were missing, that we started doing then, or the team started doing, I'm no longer working on that project, is to get more feedback from users as early as possible, to ask them what they need, and to kind of see, even at some point, just ask them, and this is what we are doing now also with the data platform. We just go to users and we tell them, okay, let's do this together. You share the screen, you work on it. I just want to see how you do it. And because even when you ask for feedback, they don't always tell you everything, because there's always this idea in larger companies that, yeah, if I say that I don't know how to do this, then it looks like my team is not that good, and there is this internal competition and so on. So if you ask for feedback, sometimes they might tell you, yeah, it all works, and then they have their workarounds in place. If you ask to see how they do it, you get to see those workarounds, and sometimes the workarounds make sense, and you want to bring them in and incorporate them into the platform. So I think this is a very, very good starting point for improvement.
Yes, I think we see any other questions over there.
Thank you. Standardization is an important aspect for a platform. What are the guidelines or the best practices to build a standardization for platform?
So usually when you start with platforms, you, even without actively making the decision of standardizing, you need to do it because you don't have the resources to support everything. So usually you agree on a standard set of tools or a standard programming language. In this kind of will happen by accident, whether you want to do it or not. What can make your platform really useful to the organization is if this doesn't happen by accident, but you do it on purpose. And I think there, it has a lot to do with not just the technical aspect, but the overall organizational structure and the goals of the organization. Like if you are going to invest in a platform that takes a lot of resources to build and maintain, you want to consider, for example, your tech strategy and hiring strategy. Like, are you going to target Java developers? Then you want to build a platform that supports Java. Do you have, I don't know, the idea to go with Rust because you need to be super fast and close to hardware or whatever? Then obviously you have a different set of requirements. What kind of security do you need, or what is your risk appetite? Do you need air-gapped environments, or are you fine with kind of a more relaxed and therefore more flexible environment? And these are questions that you need to ask yourself and answer before you can start working on a platform, ideally. And of course, think about how to adjust as you go along. But these questions force you into more or less into standardizing your stack. And then I think the best kind of guideline is the 80-20 rule. So when you look at everything that everyone wants, you need to throw out 20% of it because it would just be too expensive to achieve. So you focus on the 80% that bring the most value, and that can be done relatively easily or easier than achieving full 100%. And this will kind of give you your guidelines for standardization. It will show you what is important for the company and what is important for the platform, and you will then standardize on that. And as I said, this standardization also implies that you have this escape hatch, that use cases that you cannot fulfill with this standardized approach have a way of existing in the company. And this is very important because otherwise teams will feel pressured to fit into this standard way of doing things. And it might create resistance in the company towards the platform. If you tell people the platform is here to make your life easier, and you get this stuff out of the box that you anyway need, and if you need something else, there's still a way for you to do it, then people are more open to this and more approachable, I believe.
I think we have time and probably energy for one more question. And then since I look into your faces, I guess some of you also need a coffee afterwards. So one more question. Yes, over there, thanks.
How do you achieve that the company makes then 80% with the standard things and 20% is the, not standard and not the other way around?
Yeah, this is a difficult thing to achieve, and you cannot really, I mean, there are some school of thoughts that say, okay, management dictates what happens in the company, but obviously this just means shadow IT and means people just working around your solution. The only realistic way to achieve this, and especially achieve it sustainably in a long term, is to make sure that your platform makes it so easy for the 80% that they don't even want to try anything else. So essentially, if I want to, I don't know, one example would be I want to deploy a web service where I can just immediately go to the UI, log in with my company credentials, and see a UI with, I don't know, a table list of dummy values. Then it should be relatively easy, like self-service, click of a button or two, you get this deployed, you get your template code in it. This is more or less what we did. You get the template code for the backend, you get some template code for the front end, you get Keycloak built in that will authenticate the requests, and essentially within a couple of minutes you can go to a URL that's given to you during the self-service process, and you can just go there, log in, and you have the initial idea we had is like you have a suggestion for lunch. So we, based on the office where we are, we look at restaurants around and the menus, and then you get a suggestion for lunch. This was our template thing. And if your company mostly works on web applications that are internally facing and that need to communicate with the database and so on, and if you provide this setup within a couple of minutes by just clicking a couple of boxes and then it's clear what needs to be adjusted, then people will mostly just do it, because then they don't need to worry about the setup of the authentication. They don't need to worry about where will I find the database, who will maintain it. They don't need to worry about CI/CD pipelines. All of this is kind of built in. And it's a huge relief for them, because the rule says, well, if you build something on your own, then anytime you make it available on the internet, you need to go through a penetration test. It takes 2 months. If you go through the platform runs these things regularly. So you click a button, you get an application, it's fronted by an authorization, authentication setup, and you don't need to go through this test, because this test will anyway happen regularly. And any team that wants to deliver stuff will, just by the simplicity of the process, say, well, I will just go with this. And it has to be a very specific use case, like using, I don't know, tooling that is not available, or using perhaps very complex logic where you need specialized hardware, graphic cards, or high-performance parallel computing, where you say, okay, I need custom resources that don't fit into this platform where I need to build my algorithms that scale and so on. It's about making it easy and making it difficult. These are the two big levers that you have to play with when you build a platform. Anything that you can make easy will probably attract people. Anything that you make difficult will probably repel people. And if you get the kind of balance right, then the 80-20 should be more a goal that you want to achieve by using these two kind of levers, rather than kind of something that you try to fit onto the platform. And I think this is the key thing. It's more something that you can use to measure your success and optimize and improve on the platform, rather than have the platform drive that instead.
All right, thanks for the answer. Thanks for the insight. Amazing talk. I see you guys back in half an hour. We're going to answer the question regarding IT security and which tool to trust on your Kubernetes clusters. Grab a coffee, stay hydrated, stay caffeinated, and see you back in half an hour.